This video was brought to you by the ILC. Welcome back once again. This is episode 34, Graphing a Rational Function. In the previous couple of episodes, we've collected a lot of information about rational functions. In this one, we're going to tie all the information together and draw a graph of the rational function that we've been using for the past couple episodes. Let's give it a try. So I have the same rational function here that I've been using for the last couple episodes, y equals 4 times x minus 2 times x plus 2 divided by x minus 3 times x plus 2. On the right side, I've written all of the information that we have collected about this function: the vertical asymptotes, the holes, the x-intercept, the y-intercept, and the horizontal asymptote. Now, drawing this is not a quick process, and it takes a bit of organization to get there. First thing I recommend you do is definitely have all of this information in front of you before you attempt to graph it. Now, something I like to do is to draw myself a number line and label it with all of the points of interest that we've written here on the right. That helps me organize my graph before I attempt to draw it. We're most concerned about the first three pieces of information. This is going to help us break the graph into regions before we attempt to draw the line. Let's go to the number line and draw the vertical asymptote first. The vertical asymptote is at x equals 3, so I'm going to go onto my line and label some point over here as 3. Now, since it's a vertical asymptote, we're going to draw that as a dotted line, like this. Good. Let's also put my hole on there. I've got negative 2 comma 16 over 5. I'm more interested in the x value right now, so we'll go over here to negative 2, somewhere over this way. Looks good. And this is going to be an open circle because, of course, it's not really part of the domain. So we'll draw an open circle right there. I also have my x-intercept, which is 2 comma 0. So we'll go over here to where 2 would be. And this is going to be a closed dot right here at 2. I'll also draw a solid line here. And here's why. The vertical asymptote and the x-intercept are going to break this graph into sections. We'll call the first section, which is everything from negative infinity to 2, section A. Between 2 and 3, we'll have section B. And from 3 to positive infinity, we'll have section C. I'll also place my y-intercept on the number line right here at 0. I'll just leave a note that that is 0 comma 8/3 as my point here. Now, when I move to the horizontal asymptote, I'll place that on the graph. I'll have y equals 4, so I'll come here to 4, and I'm going to draw a horizontal dotted line for there. Now that I've drawn the horizontal asymptote, I'll continue drawing the vertical asymptote here, like this. This is still 3. I will place the x-intercept on the axis, right here at 2. I'll also place the y-intercept over here at 0 8/3. It'll be just a little bit below 3. And I'll also place the hole at negative 2, 16 over 5. So here would be negative 2. 16 over 5 is a little bit more than 3. So I'll place my open circle a little bit above. To actually graph this function, let's begin by connecting all of the points that we know. Since they're all within region A, they'll all be directly connected. We have sort of a curve here. Now, toward the left, you're going to keep going left, but you cannot cross that dotted line. We're just going to run very close to it, but we won't cross it. It'll run off to infinity at around y equals 4. Now, to graph the rest, section B, section C, we're going to need to know whether it's below the axis or above the axis, whether it's positive or whether it's negative. So let's have a look in region B. We'll first need to pick an x value that is within region B, between 2 and 3. I think a good number to use would be 2.5. So we're going to put 2.5 in for x everywhere in this function. Now to make your math a little bit easier, you might notice that the x plus 2 and x plus 2 represented the whole, so we won't need to use that part of it. Again, we'll just use the simplified form. So we'll have 4 times 2.5 minus 2 divided by 2.5 minus 3. Now we don't really need to compute this. That would be kind of a pain. All we're interested in is which pieces are positive and which pieces are negative. We know that 4 is a positive number. We know that 2.5 minus 2 is definitely more than 0. It's positive. But 2.5 minus 3, well, 3 is bigger than 2.5, and it's negative, so we would say the bottom is negative. And a positive divided by a negative will return a negative number. So region B should be negative. What the graph is going to do is continue downward from 2, but it cannot cross that vertical dotted line, so it's going to go down off to negative infinity. Now on to section C. Let's pick an x value that is between 3 and infinity. How about 4? We're going to put in 4 everywhere in the rational function where you see x. We'll have 4 times 4 minus 2 divided by 4 minus 3. We know that 4 is a positive number. 4 minus 2 is definitely greater than 0, so that's positive. And 4 minus 3 is also a positive number. So region C will return positive. Place that here on the number line. So when the graph comes back on to the function after going over the vertical asymptote, it's got to come in from the positive side and not the negative side. So you don't draw anything on the bottom part here. You'll go back up to the top. The function will come in and it will run along the asymptotes and it will not cross them. You might notice we didn't do anything for region A, but we already had a y-intercept inside of region A, and it definitely was positive. So we can tell the entire region A should also be positive. That's why we didn't worry about checking it. And so there you have the graph. The line comes in from the negative side, crosses through all of the points that we already knew about. We found that in region B, it should be negative, so it's going to continue to go down. And we found in region C, it should be positive, so it has to come back in from the positive side and run along the asymptotes. Once again, thank you very much for watching. We'll see you again next episode.